Now we are going to discuss about predicate logic and how representing facts in logic, that is syntax and semantics. There are some limitations of propositional logic. We can only represent the facts which are either true or false. PL requires a separate unique propositional symbol which takes many symbols for representing any particular fact. For example, in Wimper's world, the number of symbols it would take if there are n locations and m people to represent the fact of movement of some person. PL is not sufficient to represent the complex sentences or natural language statements. Also, PL has limited expressive power. We cannot represent relations like all, some or none. Examples: all the girls are intelligent, some apples are sweet, Sachin likes cricket. In PL, we cannot describe statements in terms of their properties or logical relationships. To represent the above statements, we need some more powerful logic such as first order logic. First order logic is another way of knowledge representation in artificial intelligence. It is an extension to propositional logic. First order logic is also known as predicate logic or first order predicate logic. It is a powerful language that develops information about the objects in an easier way and can also express the relationship between those objects. FOL is sufficiently expressive to represent the natural language statements in a concise way. FOL doesn't only assume that the world contains facts like propositional logic, but also assumes the following things in the world. Objects are real world entities, for example, A, B, people, numbers, colors, was, theories, squares, bits, umpus, etc. And relations, it can be unary relation such as red, round, is adjacent, or n-ary relation such as the sister of, brother of, has color, comes between, etc. Function, father of, best friend, third inning of, end of, etc. As a natural language, FOL has two main parts, that is syntax and semantics. Syntax, the syntax of FOL determines which collection of symbols is a logical expression in first order logic. Semantics, representing formal meaning, the basic syntactic elements of first order logic or symbols. The basic elements of first order logic are constant, variables, predicates, function, connectors, equality, and quantifiers. Constants, for example, 1, 2, A, John, Mumbai, cat, etc. Variables are x, y, z, a, b ranging over a particulars. Predicates are brother, father, greater than, with an associated arity. Function, for example, square root f with arguments listed as x1 to xn. And connectives are and, or, not, implies, if and only if. Equality is double equality symbol, and quantifier is universal quantifier and existential quantifier. Connectives are used to represent the relationship between objects. We can represent the knowledge of FOL in AI using these basic elements. There are two types of sentences. One is atomic and complex sentences. Atomic sentences are the most basic sentences of first order logic. These sentences are formed from a predicate symbol followed by a parenthesis with a sequence of terms. Atomic sentences can be represented as predicate within bracket term 1, term 2 and so on up to term n. Example: Ravi and Ajay are brothers, which can be represented as brothers of Ravi, Ajay. Brownie is a cat, can be represented as cat of Brownie. Sindhu is a mother of Ramya, which can be represented in predicate logic as mother of Sindhu, Ramya. Complex sentences are made by combining atomic sentences using connectives. Predicate logic has two parts. One is a subject. Subject is the main part of the sentence. A predicate can be defined as a relation which binds two atoms together in a sentence. Example: x is an integer, where the first part x is the subject and the second part is an integer is a predicate. The next is the quantifiers. A quantifier is a language element which generates quantification, and quantification specifies the quantity of specimen in the universe of discourse. These symbols are permit to determine or identify the range and scope of the variable in the logical expression. There are two types of quantifiers. The first one is a universal quantifier for all, everyone, everything. And second is the existential quantifier. There exists an x such that for some or for some x at least one. First we'll see about the universal quantifier. Universal quantifier is a symbol of logical representation which specifies that the statement within its range is true for everything or every instance of a particular thing. Universal quantifier symbol is for all. Note, in universal quantifier we use implication symbol syntax for all x p, where p is the logical expression or scope of the quantifier and x is bounded by p. If x is a variable, then for all x is read as for all x, for each x, for every x. Example, for all x kid of x, which implies naughty of x. This says that for every x, if x is a kid, then x is naughty. Another example of universal quantifier, all men drink coffee. Let the variable x which refers to a man, so all x can be represented in universe of discourse as below. Here x1 drinks coffee and x2 drinks and x3 drinks milk and so on up to xn drinks milk. So which can be written as in the shortened form. For all x, man of x implies drink x comma coffee. It will be read as there are all x where x is a man who drink coffee. Then the next quantifier is existential quantifier, which express that the statement within its scope is true for at least one instance of something. It is denoted by the logical operator there exists. Note, we always use and or conjunction symbol and in the existential quantifier. The syntax is there exists p where p is a logical expression and p is true for at least one value, that is there exist. If x is a variable, then existential quantifier the all x or there exist of x is read as there exists x for some x for at least one x. For example, some people are kind. This can be written as there exists x kind of x. This says that there exists some x that is kind. Another example for existential quantifier is some boys are intelligent. X1 is intelligent or X2 is intelligent or X3 is intelligent and so on up to or Xn is intelligent, which can be written as there exists X, boys of X and intelligent of X. It will be read as there are some X where X is a boy who is intelligent. And the properties of quantifiers are in universal quantifier for all x for all y is similar to for all y for all x. In existential quantifier there exists x, there exists y similar to there exists y, there exists x. There exists y for all y is not similar to for all y there exists x. Note the following. The main connective for universal quantifier for all is implication. The main connective for existential quantifier there exists is and. More examples in quantifiers. All birds fly. In this question the predicate is fly of bird. Since there are all birds who fly, so it will be represented as for all x bird of x implies fly of x. It will be read as there are all x where x is a bird who fly. Every man respects his parent. Here the predicate is respect of x comma y where x is equal to man and y is equal to parent. Since there is every man, so we will use for all and it will be represented as for all x man of x, which implies respects of x comma parent. It will be read as there are all x where x is a man who respects his parent. The third example is some boys play cricket. Here the predicate is play of x comma y, where x is equal to boys and y is equal to game. Since there are some boys, so we will use there exist, and it will be represented as there exist x boys of x and play of x comma cricket. And the next example is not all students like both mathematics and science. Here the predicate is like of x comma y, where x is equal to student and y is equal to subject. Since there are not all students, so we will use for all with negation, and it will be represented as follows. Not for all x. Student of x implies like of x comma mathematics and like x comma science. Thank you.